Hey everyone, welcome to Kaggle Competition Master. Today we'll work with Kaggle competition, which is our first Kaggle competition. We have picked US patent face-to-face matching, which is to detect novel semantic similarities between meaningful information from US patent application. We have been given with introduction, dataset, key concept, which is model characteristics, Kaggle results, improvement, and future scope. What is our abstract? So what are the patents? Patents are a form of intellectual property granted in exchange for the public disclosure of a new and value invention. Patents are something which is very valuable. It is an intellectual property which has been granted by CPC of US. The scope of this project goes beyond the simple face-to-face matching. Just not It is not just face-to-face matching, it is also a context matching. So for example, bird and Cape Cod. It might sound like it is completely different words, but if you see the meaning in context to house or in context to scenery, so in that case, it might be similar. So we have to match the context as well. Dataset. So we'll be using Kaggle dataset, which has been given by Kaggle. It has 8,000 unique entries. There will be two variants of testing dataset, which is seen and unseen. The unseen testing dataset will have approximately 12,000 unique records, which will gauge our model's effectiveness. Coming on to dataset, we started with 5 column identification. Okay, so here ID, anchor, target, context, and score. Our main columns would be anchor and target, and the primary method for the evaluation of this final result would be Pearson's correlation coefficient. That would be that would be used for grading purpose for the Kaggle competitions. Okay, so approach. Which approach we took? So we took and we chose BERT model. BERT is called bidirectional encoder representations from transformers. BERT is a typical neural network which uses a transformer model. Okay, so for example, it goes both direction from left to right and right to left. And BERT is actually effective for most deep learning understanding tasks because it doesn't have just normal similarity but contextual similarity as well. And the final model we selected from the BERT only, we used DBERTA V3 large. You can use any DBERTA model. It might be DBERTA small, base, or large. The results will vary as you go along with the higher models. Why BERT and why DBERTA? So BERT could be used for phrasing embeddings. So basically, embeddings generated by BERT are not only normally similar or similarity has been also included in terms of context, and it has been pre-trained on large corpus of text. And BERT has been already trained on large data, which is like books, Wikipedia, and a lot of large articles and all the text data which is available on the internet. And we chose DBERTA, which is DBERTA is nothing but enhanced BERT. We call it decoding enhanced BERT. It has been developed by Microsoft, and it has also been used as a BERT successor. It is very highly trained with Wikipedia, Common Crawl, and a lot of other large-scale datasets. Next, we will talk about our model architecture and our training configuration. Our model architecture involves the Berta model, base, and large. You can use base if you don't have that much memory, and if you have good enough memory, you can use large as well. We use pre-trained Hugging Face models. In terms of CLS token, we use one regression output. We check MAC as a loss parameter. MAC stands for mean square error. For the optimizer thing, we use Adam optimizer and linear scheduler, which used by us in this context. Training configuration, we used 80 epochs of 4 faults each. So we did 4 faults and every fold has 80 epochs. And bed size was 16. Our metric was Pearson correlation coefficient, and our validation score was 0.82. What was our training approach? Our training approach was to import the relevant datasets and packages first. Then we'll tune the model hyperparameters and then do a four-fold cross-validation. And every cross-validation will have 80 epochs with 16 bed size. Okay, coming back to the magic. What worked for us? First thing first, text pre-processing. Making it to lowercase and special character removals was the first and foremost important thing which worked. AWP was the second best thing. Though we couldn't implement AWP, you can use it AWP, which is easy to integrate. I have linked my code and a GitHub repo as well. You can use Mixout, you can use SVR head, and MSC and four folds were amazing to get us the good results. How much time it took to run the code? On Kaggle, it took 5 hours. For public score, you can see we improved the score a lot from 0.80 to 0.85, I suppose. Though it took it in our local computers as Kaggle's memory was limited and we were out of the competition. Finally, if you want to improve this project, you can use large model with smaller size and higher epochs with 4 to 5 fold of training. You can use hyperparameter configuration in terms of hit and try. So for example, if you hit with higher epochs and lower bed size to get good result, you can increase the folds as well. And I feel like if we can use Google Patent Repository and Google Patent Face Similarity dataset, like which is equivalent or similar to Microsoft Deepwater model, it can also give us good output. And I feel the others different NLP models for this task can be also considered. But as in when if you require to get it above 0.90, then it is fine. Otherwise, I feel the Berta large was good enough model if we do proper hyperparameter tuning, and we need to make sure our model doesn't get into overfitting zone. So yeah, I feel the Berta V3 large is a good choice. Okay, let me know if you have any questions in your comments, and I will all the links shared in my description. Thank you so much, guys.